This video, we're going to be talking about how we can graph sine and cosine functions. To start off with, you might want to look at the graph on your graphing calculator just to get a sense of what it looks like. In your graphing window, you can type in just sine of x and graph that. Hopefully you'll be able to see that it is a curve that continues from left to right. It never ends. So we'll have a domain that is all real numbers. But you'll also hopefully see that it has a limit to how high it goes and to how low it goes. So it's got a min and a max there. And if you understand the unit circle, you might be able to guess what those values are. On the unit circle, we never go past +1 or -1, and so that's actually our range. And when you graph it, you can actually see on your y-axis that the curves are not going past 1 or -1. Here's what your calculator is doing when it graphs it. You could practice evaluating some of these angles for the sine function there. And we could actually plot it by hand. Not necessary that we do this every time, so we're just going to do it this first time just to understand what our calculator is doing there. If I plug 0 into sine, sine is looking for the y coordinate at an angle of 0 radians. So make sure that you are in radian mode on your calculator, otherwise the graph will look very different if it's in degree mode instead. So make sure you're in radian mode. The sine of 0 is 0. The sine of pi/6, that's the y coordinate for an angle at pi/6, that's 1/2. The y coordinate at an angle measuring pi/3 radians is the square root of 3/2. And at pi/2, that's straight up on the y-axis. That's going to be our maximum value of 1. So we can start to plot that on our graph, 0, 0. Pi/6 is going to be a decimal, slightly less than 0.5. Pi/3 is also a decimal value, a little bit more than 0.5. Sorry, half of pi/2 is what I'm talking about there. And then pi/2 is going to be our maximum at 1 on the y-axis. So there we have our curve reaching its maximum. It's going to be symmetrical on the other side, just going back down to the x-axis. So notice that these values in our table are going to repeat as we go down from 1 back to 0. And then what happens is we're going to be symmetrical again, just in the negative y range here. So same exact values one more time, but they're negative. And we get down to -1. And then we work our way back up to 0. So by evaluating all of those intervals on our unit circle, we can see why the graph becomes this curve. And there's one more thing that you can do. Lots of YouTube videos have similar things here. This happens to be a nice one. So we can see how a circle is going to give us values that become a curve on the coordinate plane. Back up one more time here. So as we increase our y values on our circle, going up the circle, our curve is increasing on the y-axis. It reaches a maximum point right here at that pi/2 or 90-degree angle. And then it's going to start plotting y values as we go down our circle. So notice that the y values are going to go back down until it reaches its intercept here. And then what happens is it's going to start evaluating y values on our circle that are below the x-axis. So they're going to be negative y values. And they're going to increase and become more and more negative until we reach that minimum value. Right there. And then our y values are going to start to go back up towards 0 or become less and less positive. So our curve is going to go back up towards that x-axis. finishes off right here just past 6 on the x-axis. That's 2 pi, or about 6.28. So again, that's how we can get values on a circle and plot them on a coordinate plane, and it becomes a curve. So there's the sine curve. A couple of vocab words that we need to know when we're graphing trig functions. A period is what we name a complete cycle of a curve. And by that we mean we have values that don't repeat at all in that cycle. As soon as it ends, it's going to start just repeating again and doing the exact same thing. So the non-repeated values right there, or as it's sometimes called, just a full cycle, is called the period. There's a mathematical equation defining that period length. It's 2 pi divided by the b value. So we go back up here and look at our generic form of our sine function here. The b value is going to be the coefficient in front of the x value, or the input of your function. So in its most basic form, that b value is going to be in front of x right here. It's an invisible 1. So if I think about my equation here, 2 pi divided by 1 is going to give me 2 pi, and that's why we see one cycle happening within 2 pi radians. Amplitude is how we describe the height of the curve. Be careful, we're not talking about the full height from the max to the min. We're just talking about just the height of the curve, because this is a reflection of it, just in the negative version. So this height is the same as this height. Maybe you think that this length is negative, but when we describe a height, we're going to say that that's a positive value. So the equation for amplitude is the absolute value of the a value. So that a value in front of your trig function is going to determine the height of your curves. Always describe it as a positive value. And so your range, therefore, is going to be the difference between your min and your max, or the negative amplitude and positive amplitude. All right, let's talk about the cosine function. Once again, you can plot it or graph it on your graphing calculator. Take a look at what it looks like. As it turns out, it looks nearly identical to the sine curve. The cosine curve just got shifted pi over 2 radians. So rather than starting here, now we're starting at the maximum at the origin and on the y-axis. Otherwise, the domain is the exact same. It never stops moving left or right. And the range is also the same in the most basic form there. It's going to have a maximum of 1 and a minimum of -1. In this next table, I want to show you that we don't need to evaluate every single point on our unit circle to do these graphs. What we can actually do is evaluate what are called key points, those being points that give us any of our intercepts or max or min values. Those are the most important things about our graph anyways. And so if we can make sure and plot those points and then connect our points with our curve, then we don't have to do all the individual points. We're just going to sketch it out. So let's practice evaluating cosine here on a table. Cosine is looking for the x coordinate at a point given these radian angle measures. So if I plug in 0 radians, cosine of 0 is going to be 1. I'm all the way right on my unit circle. At pi over 2, I'm on the y-axis. Our x coordinate is always 0. At pi, now I'm on the farthest left side of my unit circle, with a radius of 1, so my x value is going to be -1. 3 pi over 2 puts me back on the y-axis, so an x value of 0 again. And 2 pi is going to be our full rotation, getting us back to where we started, so it's going to be the exact same value as 0, or +1. So what we can do is we can just plot those points at 0, 1, pi over 2, 0. At pi, we're at -1 at the minimum. At 3 pi over 2, we're back at 0 on the x-axis. And at 2 pi, we're back up to our maximum at 1. So notice that the sine curve looks somewhat cup-shaped, and the sine curve looks somewhat S-shaped. So if you're ever confused and don't remember which is which, that's at least how I kept it straight in my head when I was learning. So your cosine is always going to start at a maximum value, go to the intercept, dip down to the minimum, back to the intercept, and up to the maximum. So there's one period of our cosine function. If you know about even and odd symmetry, even symmetry is another way of describing symmetry across the y-axis. So you can see our cosine function does that, where this is an exact reflection of this, whereas our sine was not an exact reflection across the y-axis. This hump above the x-axis is not reflected over here at all. It goes down. So this is actually reflected across or rotated about the origin. If I was to rotate this around, it would line up here. And that is what's called odd symmetry. So cosine and its reciprocal function secant are even functions. They're symmetrical across the y-axis. And all the other ones are odd. All right, let's practice graphing. In the next lesson, we're going to focus on the vertical shifts and the horizontal shifts. In this lesson, we're specifically just focusing on these A and B values, which are going to be vertical and horizontal stretches. Again, to graph, we're going to identify the amplitude and the period, and then we're just going to assign 5 key points that we want to evaluate, and we'll just connect those using those shapes that we just practiced. So what does the A value do? Let's investigate that. In this function, 1/2 is our amplitude, that A value. So I know that my graph is not going to go any higher than 1/2 or any lower than -1/2. My period is just going to be 2 pi divided by the B value. Well, the B value is 1 here, so my period is not going to be any different than what we were doing up here. It's just going to be 2 pi long. So what I'm able to do now is I can set my starting point at the origin. I haven't shifted at all. And I know my period length is going to last until 2 pi. So I'm going to count 4 interval lengths away from my starting point. 1, 2, 3, 4. And I'm going to break that up into 4 intervals. So half of that would be 1 pi. Half of that would be pi over 2. And in between pi and 2 pi, exactly in the middle, would be 3/2. If this is a half, 2/2 is a whole, 3/2 would be 3 parts, and 4/2 or 2 pi would get me to my end. So I'm breaking my period up into 4 equal intervals, and now I just have to plot my points at those 4 points. At 0, I know that my cosine graph is going to start at my maximum, or my amplitude, 1/2. Knowing the behavior of the cosine graph, I know it's going to hit my intercept next, as long as I haven't shifted. Then it's going to go to my minimum point, and it's going to go back up to my intercept, or x-axis, and then finish off at my maximum point. Eventually, what we're going to be doing is we're going to plug those values into our function, because when we've shifted, it may be a little bit more difficult to plot those points just in our head. But for now, just because we're doing some basic ones, that's all that's needed. So that was an amplitude of 1/2. Let's see what happens if we have an amplitude of 3. Maybe you're thinking that if this shrunk it or squished it vertically, this must be stretching it or expanding it vertically. So now our amplitude is 3, that A value. So my range is going to go from 3 down to a minimum of -3. Once again, our period is the exact same length. We don't have to change our x-axis here at all. And once again, the cosine pattern is going to start at the max, go to the intercept, go to the minimum, back to the intercept, and then finish off at our maximum again. So that a value seems to be stretching our graph vertically. If that a value or amplitude is a fraction between 0 and 1, it seems to be shrinking. And if our a value is bigger than 1, it seems to be stretching or making it wider. All right, let's investigate what the b value does to our graph. You might be thinking if the a is a vertical stretch, then maybe b is a horizontal stretch. You'd be right. Let's take a look at some graphs and see why that's true. In this function, our amplitude is 2. So on our y-axis, we know we're going to have a maximum of 2 and a minimum of -2 for our range. But now notice that we have a b value. So let's figure out what the period is based on that b value. Our period is going to be 2 pi divided by b. So 2 pi divided by 2 is going to be 1 pi. So if I was still using this x-axis, my period range, which went from 0 to 2 pi here, is now going to get squished horizontally, and now it's going to happen and fit one period in between 0 and pi. No need to squish yourself when you're sketching a graph, though. So what we're going to do is we're going to set up our intervals, our 4-part interval here. We're going to start at the origin. We're going to count 4 spots away, 1, 2, 3, 4, and we're going to put the end of our period there, so pi is right there. Break up that period length into 4 equal intervals, so half of that would be pi over 2. Half of a half would be a quarter, or pi over 4. And so if each of these 4 intervals is a quarter here, that's 1 quarter. 2 quarters is a half. 3 quarters, 3/4 pi. And 4/4 will give us to the end there. This time we're using a sine graph, so we're going to start on the x-axis. The next key point is going to get us to our maximum at 2. It's going to dip back down and become an intercept. The next key point is going to get us to our minimum value, and then we're going to finish off back on the x-axis. So there's our S shape. All right, so there was one version. Let's see what happens when we change. This time our b value is going to be 1/2. That was a little typo there. Make sure that's 1/2 there. So our period, 2 pi divided by b, is now going to be 2 pi divided by 1/2. Dividing by 1/2 is the same as multiplying by 2. So 2 pi times 2 is 4 pi. So our period length is now 4 pi, which isn't even going to fit on my paper. So we're going to imagine it. Half of that is going to be 2 pi. Half of 4 pi is 2 pi. So I can get at least half of my S graph here, or sine graph. Again, we're going to start at 0. Our amplitude is the same, so we're going to climb up to our maximum at our next key point. And then back to the x-axis. It would be at our minimum here at 3 pi, and then at 4 pi, somewhere over here off the paper, we would see the end of our period. And so we can easily see, I hope, that we stretched our graph very much horizontally. So that's what our b value does. It can squish it horizontally, or it can stretch it horizontally. In this case, the b value is kind of the opposite of what the a value was. This time, if the b value is greater than 1, it's going to be a horizontal squish. And this time, if the b value is a fraction in between 0 and 1, that's going to stretch it or widen its period. So the b value is stretching that period length. All right, so there's some of the basics when we're graphing sine and cosine. In the next couple of lessons, we're going to get a little bit more complicated. We're going to start adding vertical shifts and horizontal shifts, which are sometimes called phase shifting. Gets a little trickier, so make sure you get these basics down and be ready for the next lesson.